No, it did it okay. It was actually 97, by the way. If you look at the big BGP, so. Hello, my name's Avi Friedman. I am now with Server Central, and I'm here to talk about whatever you guys would like to hear about BGP. This talk is oriented as an intro. We have done sort of more intermediate level. And I guess the question that I have for the people who are not here just to heckle is what you guys would like to actually, at what level you would like this tailored to. So again, ignoring the hecklers, how many people are curious about BGP but have not actually turned up BGP themselves? Okay? And how many people have basic BGP that they figured out how to set up multi-homing, or they had some people help them and are curious about how to grow beyond that? Great. Then this presentation is just right on, and we'll try to ignore the hecklers. So we're going to talk a little bit about connectivity in general, what it means, how you get your IP addresses connected to the net, how some concepts around multi-homing with autonomous system numbers and address space, how you actually are connected multi-homed without using BGP, and then a bunch of topics about BGP itself, BGP routes and peering sessions and autonomous system numbers, and some of the flexibility built into BGP to control how you see the world and how the world sees you when you are multi-homed. And we'll have a little bit of a detour talking about hardware to support multi-homing, and show some configurations and talk about a little bit about some best practices. We actually have fairly limited time for BGP intro. I think we have 90 minutes, and I'll give you some links to some additional material, including a BGP 102 that gets more into scaling. So, if you're trying to get to the internet, the most important thing to remember is the reverse path, right? You have to get your packets out, and people have to be able to find you. The way that people find you is by making sure that your upstream providers are telling everyone else that they know how to get to your address space, either because you're using IP addresses in their address space, in which case they're already engineered to take care of it, or if you're bringing addresses to the table, they need to advertise them, or using BGP, you would advertise them to them, and then they would send it to everybody else. Full internet connectivity means that the routes that cover your address space have to be seen by all the important networks out there, basically every network out there. When that doesn't happen, you get things like Cogent and Level 3 and Cogent and Provider A and Cogent and Provider B and Cogent and Provider C not being able to see each other. So without BGP, multi-homing works just fine. A little bit of a complication in terms of whether providers do or don't want to let you use their address space. How many people here have only provider address space? They don't have provider independent space yet. Okay, so we have one. And everyone else has, how many people are still running a mix? They have some space from providers, and then they have their own space from a registry. Okay, makes sense. So again, the important point here is to get traffic back, you need to have everyone know how to get to you. So I think the best way to think about a route is a promise. If I send you a BGP route, or any kind of route, it means that I'm promising that if you give me packets for that destination, that I can deliver them at least as well as anyone else. So if I advertise 17, I promise that if you deliver traffic to me for anything inside that, I know how to get it there. And if you are a single home customer of mine and I give you address space within that, the entire world doesn't actually need to know about your /24. It's when you multi-home that you need to advertise the 24 out both paths. You need to advertise it so that you can become multi-home. So you have to make sure that all these promises are heard by everybody, and you need to remember that when there's connectivity problems, it's also the reverse path, which is controlled by you sending these routes out or your providers advertising the routes for you. So again, The routes go one way and the traffic goes the other. I tell you that I know how to get somewhere, and thus the traffic will flow. It's much easier to control your outbound routes. You can always type IP route, whatever, whatever, than your inbound, and that's something that we'll talk about as we go through this. How many people here who are just learning BGP have Cisco only network? Juniper only network? Netgear only network? Okay, so people generally are working with multiple vendors. I'm going to use Cisco terminology here because that's probably the most widely deployed platform that people are using BGP. How many people use primarily Catalysts, Catalyst 6500s for routing, for BGP routing, switch routers? Okay. Oops. Okay. So, getting outbound packets to go well, we're talking now about how does it work when you're multi-homed without running BGP. So pretty simple. You set your default routes. You set your policy. It could be that I use both of my links equally. It could be that I prefer one link and then one of them as a backup. Obviously, if you have a more complex topology where you're not doing this all on one router, then you get into some IBGP issues, which we'll talk about. And you can use you can use weights to say this is better than this. And with most routers nowadays, including all the switch routers that people are using, the way this happens, you can think of it as whether it's hashing or route caching. Basically, it's not every other packet that will go out multiple links when you're load balancing, because that would be very bad for TCP going to remote destinations. It's to get either to get to a location or to get from an IP in port to an IP in port will typically go one way. So again, not using BGP, pretty simple to do outbound. To do inbound, you just have to tell your provider what address space and they magically make it happen. There are some advantages to running this way without BGP, which is you can just call up your providers and complain, and your routers, if they're unstable, probably won't affect people actually getting packets back to you. If you're running BGP and you don't run a stable network, your problems are amplified. Your connectivity problems become amplified over if all of your routing logic lives at your provider. But generally, the reason why people do want to run BGP, even if they're only multi-home to two providers, is because it gives you a lot more control. Someone calls up and says, hey, my UUNet connectivity for you is going crazy, and they say, yeah, we know that. Or they may say, we have no idea what you're talking about, but you have customers and you can see that, and then you can try rolling all your outbound traffic to one of your other providers, and you see it's better, and boom. So that's pretty much state of the art. The internet is basically a bunch of people using very simple config language, and it's very much like a bunch of garage mechanics banging on routers with wrenches, and people complain, and then you make a change, and if people stop complaining, you leave it. So that's generally the way things work. So if you're going to enter the multi-homing space, you need some address space. Sounds like most people are familiar with that. How many people here are planning to multi-home but do not yet have an autonomous system number? I see that someone actually just grabbed 4969, the company that bought the assets of the company that I had started, which then merged with someone, and their assets were bought by someone else, gave back the AS that I used to use, and that was just reassigned. So anyway, everyone's got an AS, and you have an RIR that you can talk to. So. Your providers, if you're going to start running BGP, may require that you enter your routes in a routing database. How many people here are doing multi-homing but have never played with a routing database or routing registry? Okay, so we can provide some links at the end. I generally recommend that, as people have recommended to me, that people use AltDB, which is free, unless your providers have some specific database that they run that they want you to be in. Normally, the idea is any generally accepted routing registry you can register your policy, your autonomous system, your routes with, and any of your providers that are doing filtering will pick that up from you. And the idea there is that it gives you the ability to register, to tell the world, this is my intent, these are the routes that I may advertise, and you don't actually have to then email your provider and say, please extend my filter, because they may be able to actually just run a program that generates the filters for the routers. And why is filtering important? We'll talk about that. EBGP, by default, when you run BGP, will send everything to everybody, which would be a big mess if the internet actually ran that way. So you have aggressive filtering. It's very important that everyone know what they should be allowed to get from a customer. So, oops. Okay. So on the provider side, there's a little bit of complexity. If I've got address space, that's actually not N-layer address space. If I've got address space that I had from N-layer, and they announce it as a /17, but I've got only a 24, and then I have my new provider announce just that 24, all my traffic's going to come in on the Sprint connection. Any of the non-hecklers, why is it that all my traffic would then come in the Sprint connection? More specific, okay. So, in what dimension? Right. So I said non-heckler, but I guess Patrick doesn't take direction well. Wait, he used to work for me, and I know that. Okay, so not using BGP, why would you want to use BGP? Is you get more control of your destiny. It used to be that it was a little bit more dangerous because something which we're not really going to go into in great detail, BGP route flap damping. People used to use so that the unstable sections of the net, they used to actually say, wait, if that section of the net, if those routes are going up and down, we're going to stop knowing how to get to them for a while. And then it was really a problem because if you were very unstable, you could lose connectivity to major networks for hours at a time. Not as much of a big deal now, although there's still some instability some greater risk of creating instability when you run BGP. But the key thing is it gives you the ability to respond to customer complaints. You can take a whole remote network like N-layer or Sprint or Level 3 and try moving it. You can do it on a per prefix basis, and it gives you a little bit of control on the inbound side. Not as much control, but a little bit of control over how people get to you on the inbound side. So why BGP? Well, there really isn't any other option. There's no magic ESP network of static routes that people transfer. BGP's worked well enough, even despite the fact that it's got major problems, and that it's the only exterior gateway protocol. It's the only protocol that networks use to tell each other about their routes on the internet. The BGP goes pretty much in the Wayback Machine, so actually before I started playing with routers. It goes far enough back to anyone remember, any of the non-hecklers remember ANS, the backbone? It goes back to when there was acceptable use of different networks that made up the internet. There was commercial internet, there was research and educational internet, there were things that you couldn't do. And built into BGP was the idea that you might have policy and say these routes are only allowed to be seen here, only certain kinds of traffic and certain kinds of policy. So what's actually very good is that BGP was built to give people a lot of flexibility about how they wanted to treat routes as heard from different locations. And again, why is that important? Well, if you're multi-homed, you're going to hear the same, for generally available routes, you're going to hear about that route, we call it a prefix, from many different providers. That gives you multiple paths, one for each provider, to the prefix. And the policy lets you decide which paths you prefer. Now it happens that how many people are multi-home but don't really do any inbound playing with the routes? You don't do local prefs or padding or anything like that? I mean, the fact is, it actually works pretty well. It actually load balances reasonably well if you buy from reasonable providers. But running a network of any complexity, you want some of that policy flexibility. So BGP is a routing protocol. It's an exterior gateway protocol. It's the only protocol used to do this right now. It's got some RFCs around it. We currently use BGP version 4. It's been a long time since anyone knocked on my door with BGP version 3. Most of the Proteons and Wellfleets have long been retired. It's a distance vector routing protocol for any of you computer science geeks. It supports classless routing, which we don't really need to go into now because everything does. And the idea is to tell other networks about the prefixes, the routes, that every other network is responsible for. If you see NLRI, that's a fancy way of saying route, network layer reachability information. That's just something the protocol.
So one comment, the RFC has been updated. It's now 4271 is the basis of BGP. 1771 has been completely invalid for actually producing a working BGP for many years, and they finally got around to actually making an RFC that's kind of accurate how BGP works. So,
would you please send me emails so I may update the slides?
Yes.
Thank you. Well, there were those things like weights and other things that people did that weren't really in there, that sort of like the whole path selection thing that, anyway. So in BGP, networks are autonomous systems. Each network has an autonomous system number. or more, one or more autonomous system numbers. So the routes are exchanged between autonomous systems. In BGP, every AS is the same size. So UUNet is the same size as a single router network. When you look at the route, all you see is that one autonomous systems contribution. In BGP, you don't actually see anything about the internal topology of the remote network unless they put some markers on there that give you some clues that you can look at called communities, which we'll talk about. But you don't see 10 copies of it just because that network is bigger. BGP doesn't know about link congestion, link size, pipe size, anything like that. It just tells you, I have heard from this network that I can get there. The distance vector protocol is pretty much a whisper down the lane. It's, I heard from him that he can get there. The next guy, that guy says, oh, I heard this, and here I am that I can get there, and then on down the line. Another interesting point, the autonomous system numbers are stamped on the routes on the way out of a network. One way you can remember this is it's possible to write a BGP implementation that sends routes without actually putting the AS on it. So there were early things with route, in fact, people do that with route reflection, that you can, at an exchange point, share routes between people without having your AS in it. So if you're trying to think in your head, does the route on my network have my AS in it? The answer is it doesn't. And the way that you know that the AS is only on the way out is that you could write software that will transfer routes without actually having an AS in the middle. So no concept of pipe size, congestion, anything like that. One of the things that is actually the first learning when you start playing with internet routing is a lot of the hidden complexity that you might think is there isn't. It's just a bunch of dumb stuff involved with with vendor routing bugs. Of all different kinds of vendors have bugs. And you just need to know the simple stuff well enough that when you see a problem, you can sit down and say, what should be happening? And you earn your routing engineer bones the first time you find out that something that should be happening but isn't is due to a bug and not due to your misconfiguration. And it will probably only take you about 5 different routers or 20 tickets or something until you find the first bug. But if you know what should be happening, routing is deterministic. There's no magic man in the router making stuff go one way or the other. If a link fills up, it's just going to sit there pegged unless it stays so pegged that routing protocols can't even run. So why does BGP have the AS path? We'll actually talk a little bit about what's inside the route. This was not immediately clear to me, all the reasons why you needed to have an AS path until I actually started looking at confederations and route reflectors and some of the advanced scaling stuff. The first thing is, without the AS path, there'd be no way to do loop detection. So first fundamental reason design of the protocol, the autonomous system path, which is the autonomous system numbers that get built up as the route traverses, let you do loop detection. In internal BGP, you don't actually put your AS on it, and so there's a rule that gets a little bit confusing, which we'll go into, about what routes can go where. And that rule exists mainly because there's no AS path to do loop detection. Second thing, again, we talked about when BGP came about, it was in this world of policy routing, which doesn't mean what we mean now by policy, but what routes are allowed on what network, and so setting policy. You can say, either because there's a problem you're trying to get around or because you don't want certain routes to go somewhere, you can say, if the route has this, was a sprint route heard from UUNet, then depreference it, or drop it, or do something else with it. And when you're routing Fugros, you can actually look at the routing table, and you'll know the AS numbers, and you can actually pretty simply inspect what's going on as you make changes. So BGP and ISS, we have these hockey pucks that are the routers, we have clouds that are the networks, and you've got different networks exchanging traffic via different links. Now, in general, most of these networks would have more than one router, but again, to BGP, it's all one AS. It's one representative, even if you talk to that network via multiple different connections. So more concepts. In BGP, the peering sessions, the way that the routers talk to each other are over TCP, over peering sessions. There's keep alives at the TCP level, but also there's a BGP message that is a keep alive. Inside the routes, it's just a pretty flexible set of these things called attributes. So the route is a little mini database, And it's got things like what are the IP address, what's the autonomous system path, and then it's got other attributes that we'll talk about. And one of the nice things about the structure is you can actually extend those in well-known ways, or if you want to make your own attributes and send your BGP key in it or something like that, you could do that too. It used to be easier to do that without breaking the internet. Now more and more routing vendors have started reading RFCs, so it becomes less possible to send wonky stuff in BGP. But BGP has been extended for IPv6 and multicast and lots of other things that it wasn't originally designed for because it's because the attributes can be easily added. Another thing that's important in BGP, there's only one best route for any given prefix at any given time. What does that mean? Well, early on, I had a customer, I was connected to Sprint and Usenet, call them. And a customer of mine said, I want a full routing table, but only of Sprint routes. Well, you can't do that unless you're writing your own, unless you're doing really weird Richard level bizarre things with routers. You can't really do that because if I'm going to load balance my traffic, then I'm going to have half my routes from provider A and half my routes from provider B. But I'm only allowed to send the best path, the best path to that prefix. So if half of my routes, let's say from Usenet and Sprint, half of them from Usenet, I can say only send Usenet routes, but then I'm only going to send that person half the routes. And that's really important, and it comes up again and again in BGP. You could only send the best route. If you could send routes that were not the best route, that way lies madness, or at least massive looping of packets all over the place, which we try to avoid, which is another reason why when we talk about weight, we'll tell you not to use that BGP weights. So the best route is the one that you can send. Another interesting thing for debugging, the best BGP route is not necessarily the route that the router is using, because there are multiple different routing tables in the router. So you can send the best BGP route, but of course you may have direct connection to something that overrides the routing table, the external route, and then that may be the route you're using, but in BGP land, it will be completely agnostic to that. So with BGP, I turn up a session, and then all the best routes are exchanged. Then over time, just the changes get exchanged. So turn up a session, and with EBGP, which we'll talk about, I'm going to try to send you, whether you're my customer, my peer, I'm going to send you every route that I have, or for every BGP route that I have, the best path. That's what I'm going to try to send you a copy of, through whatever filters I have, then it'll make it through whatever filters you have. So if you take a session down and then bring it back up again, that whole process starts again. And we'll talk about this a little bit, but that's a very bad thing to have happen. You really want to avoid that. So basically, what happens is every time I send you a route, you have to look at it and say, is this the new best BGP route? And if it is, send it to more routing tables in your router, and then send it to the line cards in your router. And then if it was the best BGP route and you advertised the other route, you need to send it to all your peers. And this cascades. And so there's a lot of work that's gone into BGP to make sure that you don't take sessions up and down, and changes to policy can be propagated just incrementally. Someone's online. So inside the router, basically you can think of it as following. I apologize for not having a fancy diagram. There's routing table specific routing tables, routing protocol specific routing tables. So BGP has a routing table. The best route from BGP makes it then down into a big IP routing table. Now you've lost information when that happens. You don't keep the autonomous system path. You don't keep the origin. The things from BGP get wiped, and you have the IP routing table, and there's some concept of where that came from. Then there's more of a forwarding table, and the exact implementation depends on what router you're using. But then there's a forwarding table, and then that may or may not get distributed to the forwarding tables on the line cards of the device. So the best BGP route, what's actually causing the packets or to flow within your router isn't itself a BGP route, but it's a BGP route that became an IP routing table route that went in and became a forwarding table route. So each time you get a BGP update and something changes, there's more work that has to happen within the router, which is why even though router CPUs are very fast, there's still some scalability issues, and you don't really want a very dynamic network in terms of routing updates, or you can have problems. And every time a route flows downwards, it gets not more specific in terms of number of IP addresses, but more and more context is lost, so that the line card doesn't need even to know where the route came from. It just needs to know from here to there. So basic BGP configuration, you're going to have an IP address on an interface. You've got a network that you want to announce. We'll talk about some more concepts about this, but I thought people would like to see a basic configuration. You've got a route that you want to create in BGP. That's the network statement. There's someone that you're going to peer with. There'll be some other things that you'll enter as neighbor statements as well. And the one thing you should always be thinking of is filtering outbound and filtering inbound. You're going to send your routes out, and you've got some bogons that you don't want to get in. Bogons, in the generally accepted term, IP addresses that shouldn't be seen on the internet. But when you're talking to an external provider, you actually also want to make sure, for example, that they don't advertise you your own address space. And the reason that this is important is actually because of AS 7007. There was an incident, and by the way, is 7007 still allocated, or is some poor soul about to actually get it allocated from Aaron? Oh, he does? Okay, good. Because I can just imagine some poor provider about to get it. So AS 7007 blew up the internet one day by, does anyone, everyone, raise your hand if you remember classful addressing? Internet addressing? Okay. So basically redistributed BGP4 through RIP v1. Now what happens when you take a 17 through RIP v1 is it either becomes a 24, a 16, or an 8. Right? It becomes, that information is lost. It becomes whatever the network number indicates the length should be, and then when you put it back. So I was in a data center, and a customer of mine called me and said, why are you advertising me a 24 when I'm advertising you a 23? And who's this AS 7007 that's originating it? And I actually happened to know at the time who 7007 was and called him to find out what was going on. What's happening was BGP 4 went to v1, which went back to BGP. So the 23 was in 192 or greater, became a Class C, then got put back in as a 24, and then redistributed through Sprint. So network hygiene, don't accept anything in your address, in your routing table from the outside. What that means is when you have a customer that is going to multi-home, it actually then is when you should put you should change your filter to allow that address space in so that you can still get to them if their connection to you goes down. So, highly recommended. So we have routes that talk about connectivity that happen inside peering sessions over TCP between networks. So inside every route is a bunch of attributes. And again, the number of attributes grows as our flexibility, what we want to do with BGP grows. So the prefix is the fundamental thing. It's a starting point in a net mask or a length. Second sort of major one, aspath. So it's the sequence of autonomous systems, each with an ASN, that the route has traversed. Lets you do loop detection, apply policy, and the AS is stamped on the way out, which means that inside your network, your routes actually have the null AS path. Well, not null, but they're empty. And in some implementations, they may be null. So in regex speak, it's $$. There's start at the beginning, go to the end, nothing in the middle. That's your routes inside your network. When you advertise them to someone else, that's when the AS goes on, and then they see it, and they can tag by your AS. So one thing to note, there's now bigger autonomous system numbers, and you may see them. There are a lot of routers out there that don't actually support them yet, and at some point when we finish allocating all the returned autonomous system numbers, that will become pretty important. So, but if you're using major router vendor, whatever, your implementations will probably support that. In the AS range, in the lower AS space, 0 and 65536 are reserved. We found that the question of whether 0 was reserved or not came up with one of the first big BGP blow-ups when the AS0 leaked onto the internet, and people that did read RFCs said invalid, and people that didn't said, hey, that's okay. And then there's a range, 64512 to 65534, that are for use internally. Now, there are cases where you'll use that to talk to another provider. Let's say you want to multi-home to the same provider, and you want to be able to change how your addresses are announced to them. You may actually grab an AS that is, actually that should be 65535. You only want to grab an AS and use it for BGP, but not have it be seen by the internet, and then you use a reserved autonomous system. So when you're pattern matching, caret means match beginning, dollar means match the end, so the null AS path, the empty AS path, is caret $. So if you want to see your routes, you type show IP BGP reg caret $. So a Sprint customer would see an n-layer originated route, caret 1239 space 4436 $. Or if you wanted to match anything that was in 4436, you put an underscore instead of the $. But when Sprint is looking at that route internally, it wouldn't see the 1239, it would just see 4436. I heard it from 4436. If you want to match, one important thing about regular expressions in Cisco speak, if you do show IP BGP reg and just type 701, you'll see 7018 routes also. It's ASCII-wise matching, not treating the numbers as numbers. So you should always, you'll use a caret, a $, or just underscore means beginning or end means it could be the beginning, the end, or it's not really a space, but a breaker. So show IP BGP reg underscore 701 underscore would match 701 anywhere in there, but only the number 701. Another attribute, which we'll sort of skip over for now, next hop attribute that says how I get there. This becomes more important with larger internal networks. With internal BGP routing, there's actually a little bit of recursion that will normally go on where the routers will peer with each other either using a physical interface or hopefully using a loopback, /32 that you use. And the internal routing protocol, OSPF or ISIS, will describe to the routers how they can all get to each other at the low level. And BGP is used to sort of map the superhighway route. To get to this external space, go to that router. But BGP doesn't tell you how to get to Chicago's router. It tells you the IP address of it, and then a recursive lookup happens underneath it. In that world with iBGP, you want to have the next hops preserved. With BGP, with EBGP, when you're talking BGP to other providers, you generally want to have, next hop will be just someone that you're directly connected to, but you generally want to say next hop self just to be sure. That really mainly comes up in a case where you've got like a LAN, and you've got a few different people on the LAN, and you might be peering with people, and routes get passed amongst them. If you don't do something, what will happen is you'll hear the next hop, not for the router that you talk to, but for somebody else's router, and you don't want to, that's generally bad. The MED, multi-exit discriminator, again, we're not going to talk a lot about it here. That's more of a BGP 102 topic. It's a number that someone can put on a route in the MED attribute that's designed to tell you how close or far away that route is. So for example, let's say you peer with n-layer in 3 different cities, you'll hear a different MED, a different metric on that number depending on how close the route is injected into that n-layer network. And the original idea was sort of that you'd take your IGP metric, your internal routing protocol metric, and stick it there. There are a lot of complexities that actually wound up coming up if you look up MED and flapping and instability over the last 12 or 13 years, because the MED only means something within one provider. You can't compare one provider's MED to another, and when you do that, there's problems. And you can also change the MED as you hear the route to be one of the different knobs or twiddles that you can do to prefer routes. But generally, we advise people to just stay away from the MED when people are starting. Of the people who are just learning BGP, how many people have only one router speaking BGP in their network? 2? Less than 5? More than 5? Okay, yeah, clear that we don't have complete coverage of the possibility space. And how many people who are the intended audience, not the hecklers, are running OSPF in their network? ISIS? EIGRP? IBGP only? Okay, so mostly OSPF. So we will skip this. So, sorry? Oh, RipV. Hey, congratulations! You can become Black Holio. I will not use RipV1. I will not use RipV1. I think most terminal servers already support only RipV2. I think RipV1 is pretty dead nowadays. So another attribute you'll see is the origin. Don't worry about it. One way you can think about the BGP origin attribute is it's sort of like half of an AS path. We'll talk about how routers select which path to the given destination is better, and origin is in there. So if you want to do some twiddling, you can occasionally change the origin, and that's actually happened at the end of a month when people want more revenue. They'll change the origin to make more traffic flow their way, but generally, like MED, you'll just sort of ignore this attribute for now. Weight attribute, the main reason I mention this is that you should not use it. There are certain more exotic cases where it's useful, and certain complex reverse path filtering topologies where you need to get into it. The interesting thing with the weight attribute is that it's non-transitive. When you set the weight, it's for that router only. The reason your antenna should go up and say danger, danger. When you do something that's on one router only in a multi-router network, you may have someone pointing a route at you, and you could point it back at them. Now, normally in well-formed uses of BGP, that could never happen. You could never be, because if you thought that you should get there through them, you'd have a route, you'd advertise it, they think that's best, they would never advertise you a route. You couldn't have that kind of thing going on. But with weights, just like with static routes, you can point static routes back at each other. With weights, it's equivalent to like a BGP really overrides static. And the original idea was if you have something that you really, really think needs to go that way, it gives you the ability to do that, but you should just stay away from it. Never set the weight. So local pref. After AS path, local pref is probably the metric that people use the most nowadays. The local pref attribute itself is local to within your network. So you won't see a provider's local pref unless they somehow magically transform it to something else called a community to tell you about it. But it's within your network, so anything that you do to it won't be affected. It's used to influence BGP path selection. So it's comes in when I look at two paths to the same prefix and say which should I prefer, I'm going to use the local pref before I use the AS path length. So one thing is you're sort of now ignoring some information that you can get from the AS path, but generally speaking, I think it's probably well over 50% of people use local pref to change how they actually, to move traffic around on their network using BGP. One subtlety is if there is no local pref attribute, then it's like there was an attribute of 100. So if you've ever done a show IP BGP and you see the local pref column and there's 90, 100, 150, and then there's empty. Empty means that the local pref was not set. In that case, it's as if it were 100. Normally 100. So it overrides the AS path. It comes before the AS path, and it's transitive. It goes to the other routers, but it's local only to your network. It's the main intermediate level knob that people use to prefer traffic nowadays. So another topic, IBGP versus EBGP. This was a little confusing to me when I was first starting, especially the IBGP part, although EBGP was too. My first peer was UUNet, and this is a sort of funny story. I was working with someone, had gotten the T3 down to DC, connected to May East, trying to read the Cisco docs and figure this stuff out. And so I asked him for help, and he didn't want to give it to me because there were a number of people that believe that if you teach people about how to do routing, that it creates more competitors and all that sort of stuff. Now there's a lot more information than it was available in 96, 97, but anyway, I had sent mail to a few people, and I got email from asp@uu.net saying, hey, would you like to peer? We noticed you're at May East. And I said, why, sure, that would be lovely. And then I tried to figure out how to set up all the filters so that I would only send my own addresses. But it was all this Cisco speak, and I didn't really understand it. That was why I wrote all those articles, was because I was so frustrated at trying to parse all the documentation. EBGP, BGP, when you're speaking to another AS, by default, you're going to send all the routes in your routing table. There's nothing you need to turn on. You're just going to start sending them unless you have filters in place. But with IBGP, because there's no loop detection by default, there are things that have been added on to BGP for loop detection, but because there's no loop detection, there's a weird rule in IBGP that says you can only send routes that you heard from the outside or that you originated. You can't tell another internal router about a route that you heard from another one because there's no loop detection by default. And if you could do that, then the messages would just loop around. So it's sort of the opposite. You would think that with EBGP you'd be more selective and you'd have to say, please to send all my routes out this connection. And with IBGP you would think you'd send all your routes fully, but it's actually a little bit reverse and that can be confusing. So corollary, you must strongly filter all EBGP sessions because it could happen that all the routes will go to you. Now, most big networks will actually use configuration management systems to manage their network, but a common thing that will happen is I'm turning up a peering session, and with the wonderful CLIs that are Cisco and Cisco-like that we're also familiar with, if you type, neighbor foo, remote AS foo, and then someone taps you on the shoulder and you don't cut and paste the rest, you have a session that might come up if there is no password before any filters are in place. And if you're expecting to only get 20 routes from someone, you always need to prepare for the fact that they might start suddenly sending you 280,000, and there are some mechanisms to deal with that. So when BGP speakers within an AS talk to each other, it's IBGP, internal BGP, and the corollary about the lack of loop detection is that in the simple configurations you have to have a full mesh. Every internal BGP router needs to speak IBGP to every other router. With EBGP is external, so you can actually have, this is also an old slide, you can actually, so with EBGP you've got different networks out there. With the hidden complexity inside 7007 is that there are actually multiple routers. Now to EBGP, the fact that there are is completely transparent. But within that network, you've got those routers, and so the FAR routers, the FAR2 routers, will be speaking IBGP and EBGP. In fact, the third router in AS7007 may well also speak EBGP to someone else, but in this diagram it would just speak IBGP and it would be meshed with the other two. So EBGP talks to one other guy, sends the one best path to every prefix in BGP, sends all the important attributes, prefix, aspath, but doesn't send the local pref or some other attributes. When you read the protocol, there's transitive attributes that get sent around, non-transitive like the weight that are local, and then there's attributes that are local to your AS and attributes that you send to other people. So usually with EBGP, the next hop will be set unless it's multiple there's multiple people speaking on the same, generally LAN, the same prefix. With IBGP rule, you can talk to routers many hops away. They don't have to be directly connected. And in fact, the recursive routing that I talked about is generally what will happen is BGP will be used to tell you sort of where generally you're going, and then you'll look up in OSPF, EIGRP, ISIS, whatever, how to actually get there. But it can only send a route it injects or route it hears directly from an external peer, requiring a full mesh. And the reason is because there's no loop detection otherwise. It sends all the attributes other than weight. It leaves the AS path alone unless you're doing confederations, which I assume no one is. And it doesn't touch the next hop unless you say next hop self. There are some cases if you have a very simple topology, and let's say you have two routers in the same data center and that's your network, you may want to reset the next hop, but generally you won't reset the next hop in IBGP. So let's say you have 16 routers in your network and you want to run IBGP by default, you're going to need a pretty complex mesh, which becomes even larger when you have tens or hundreds of routers. And there's topics that are covered in BGP 102, route reflectors and confederations that you get into to scale it. The interesting thing when you're just starting out is you should understand a little bit about it because it's actually better to set up your network with route reflectors initially, just because it doesn't add really any overhead and it gives you the ability to not have to change anything as you grow. So the IBGP restriction, we talked about that. So how do routes get into BGP? You have to insert routes somehow. You can either statically insert them, or you can redistribute from another routing protocol. How many people here redistribute from another routing protocol into BGP of the non-hecklers? Okay. And how many people use only static statements to create BGP routes? Okay. So I recommend that you stick with that until you, yes, more than once would be the ultimate question. Yes, the never-ending distributed non-converging computation that will ensue. Although actually with divergence, with partial SPF, will it actually, can it handle it? Okay. So generally speaking, if you want, there's some BGP slides, bigbgp.ppt, that are at my website, and BGP 102, I think, talk a little bit about creating BGP routes by dynamically redistributing them from other protocols, but unnecessary complexity at the basic level. So to create a route in Cisco, you say network foo. I don't think you can yet. So I think every so often I try network foo /16 or something, and it still doesn't let you, just to be perverse. It must have an exactly matching underlying route of some sort, generally a static route. Otherwise, it won't create that route. And you probably don't want to do this with 1,000 routes. At 1,000 routes, you hire someone who knows about redistributing and setting up your network. But it's pretty easy to scale this way. Generally, you'll put the network statement at the place or places closest to where your customers are. So advertising routes. BGP is inside peering sessions on top of TCP, and your peers have to be specified explicitly. There is a way to do wildcard BGP, but you wouldn't be doing that. So once the peering session's up, all the routes flood, and then there are periodic updates. And so the key thing is to make your network as much like this as possible, so all you're getting over time is periodic updates. If you have issues going on with connectivity or CPU, you can do a show IP BGP and look at the number of updates that have happened over time. Is there a MIB for that? I have something that scrapes it, but okay. So you might even be able to, depending on your router vendor, grab that and look at it. Because if you start seeing that go really high on some sessions but not others, there's some problems that you need to look at. So there's a state machine that describes how the routers speak BGP to each other. It's in the RFC. And one reason it can be useful to at least know what those states are is because when you do a show IP BGP, you'll see those states listed. And the interesting thing there is active doesn't mean active, it means waiting. So if you see active next to the session, it means the session is not up. So interesting. So every time I get a route, it's got to pass the filters, and then it can go into the BGP routing table. And then unless it's the same route, essentially, that it just had a different attribute on it, I need to figure out whether that's the best IP route. And then I need to figure out whether that's the best route for the forwarding table. Generally, IP route and forwarding table is the same thing. And then I also need to send it to any BGP peers and see whether it passes. So there's a lot of work that has to go on, and that's why you want to keep the network stable. So policy. To decide what routes can and can't go where, and what routes you want to prefer from different directions, the basic filters are prefix lists. There used to be distribute lists, but the modern form is prefix list. Lets you list prefixes. There's aspath filters, aspath access lists that let you match on aspaths. And then there's route maps that let you be more creative. Certainly not a Turing complete language, but the route maps let you give you more complexity and actually let you set or reset attributes in BGP as you for distributing to your other routers and potentially to your downstream customers. So prefix lists are just, it's to be used per neighbor. It's just a list that's matching on prefixes that's applied to your BGP routes. You can use it inbound, outbound, both, and it's based just on the prefixes. So you'll have a prefix list, call it something, have it on every router of your prefixes. And then you probably should also have at least a prefix list of routes you don't want to allow in. So you don't want to allow anything that's that's longer than a 24 or 23. You don't want to allow RC 1918. You don't want to allow your address space inbound. Beyond that, as you have customers, you'll create access lists for that or for other special purposes. So ASPath access lists, called filters. Common ones you want to keep around are permit only my routes. So you'll probably have an ASPath access list of what are your routes, which means $, and the ASs of anyone underneath you. There are reasons that aspath access lists are not enough. For example, let's say that you have a multi-homed customer, and your access list says permit my routes and permit 7007, my customer. But you don't have, I'm sorry, I got this backwards. Let's say you have a prefix list only that says allow these routes through, and your multi-home customer goes down. You'll hear those routes from another provider, and you may then give them transit. You may actually transit UUnit's path to another provider unless you also filter by aspath. So it's important to do both prefix filtering and AS filtering. In general, if in doubt, overfilter. The amount of work required when extra routes float around is much, much more than the extra work of doing some filtering in your routers. Regular expressions with Cisco are Unix regular expressions, basically, or subset 3A subpart 1 of standard Unix regular expressions. Dot means match any single character. Asterisk means 0 or more of it. So unlike DOS, where star means something slightly different, plus means that character and then more of them, question mark. In general, you probably won't use these until you get more complex, or you have providers that are telling you, giving you snippets of how to do matching on different ASs. Generally, you're going to use the caret, which means begin at, the $, which means end at, and the underscore, which means begin, end, or a break between ASs. Those. So there are also some other things for confederations, but we're assuming you're not doing that. So again, more regular expression. So when you apply aspath filtering, you set the filter inbound, and then the routes that try to get in through that filter will be permitted or denied. So if, in this case, with AS access list 10 there, if the route has 6201 or 6201 that it heard from 6202, it's going to accept it, but nothing from 701 will be able to make it into 3847 from 6201. The other major use of this is on the inbound side. If you, again, you're multi-homed, you want to try moving all your UUNet traffic, you'll say match 701, deny everything else, and then you'll set something. You'll be using a route map, and you'll set something to cause the routes to either be preferred or de-preferred as you hear them from a given provider. 3 things that you should probably always keep around, especially for the sort of oh shit, or something weird is going on and you need to do something. It's always a little dangerous when you hear the routing guy say, oh crap, or interesting, or don't, and generally they'll go reaching for one of these. You want to have something that permits everything. You certainly want to have something that denies everything, and you want to have something that permits, might be more than caret $, but your routes, because you're going to use that a lot. And it might be caret $, and there might be your downstreams. How many people here run BGP but have no downstream ASs? Good. I was wondering whether you'd raise your hand. So route maps let you combine different ways of matching on routes, but they also let you set different things in those routes. So they're like little programs, not very complex. They're also used for other things, like when you do redistribution, you'll do it with route maps. You do traffic shaping and other things. But for BGP, it says, match, if this is the case, then do this, or don't do this. So route map, some name, permit or deny, then match and set. How many people here use Foundry? Okay. One very, very important thing, just to annoy the routing engineers of the world, the vendors that are not Juniper, that have done Cisco-like, decided that they didn't actually want to do it exactly like Cisco did, because, why, that would be incredibly complex and would require someone to actually spend an evening working on. And with Foundry, you ever notice you type, neighbor, whatever, foo, and it says, warning, this may not take effect until you clear the session. So you pasting a bunch of stuff in, you get all this output. Well, one very important syntactic difference. On Cisco, it's neighbor, foo, route map name, in. On Foundry, it's neighbor, foo, route map, in or out, and then route map name. when I was playing with foundries, I actually almost became make clueless because I cut and pasted, didn't notice that the syntax on Cisco was slightly bad and turned up a bunch of sessions without route maps, which caused some complications, which we then found. So important thing to note there, if you're using a not Cisco that sort of speaks Cisco, make sure that all of the BGP related syntax is the same before you go cutting and pasting. So although generally
the other goofy one is Foundry, where Cisco uses allow, Foundry uses accept, and so they look the same, but they're not really. Like when you define like community lists and things like that, I've seen people get bit by that before, where it's not quite the exact same syntax.
Okay. So for route maps that say permit, if the first clause there, the match statement, is matched, then the route is permitted. If the route map says deny, then if the match is true, it'll be denied. So it's a little bit of reverse logic there that is sort of the way that it should work, but just you have to think about sometimes. And then if the route hasn't been matched by one of these earlier, it'll just flow through to the next sequence number until it is either matched or not. So selecting routes. Usually there'll be 2, 3, 4 ways to get to a given remote destination. We'll call that 2, 3, or 4 paths to the same prefix. It can become confusing when you call up and say, I see 3 prefixes to get there. That typically means something else. If I see 3 prefixes, it means there's more specific and less specific. But in BGP, if I have transit, full transit from 2 providers, I'll have generally 2 paths for every prefix, and then I have to pick the best one. The really important thing to note is it's not random. The net effect, if you don't do any tuning, is that you sort of get statistical aggregation that can sort of seem like either randomness or magic, depending on the way you look at it. But it's not random; it's deterministic, which means you can always look at the input, apply the rules, and figure out what's going on. Hold on. There is an exception. Certainly, if you have multiple routers with the same router ID, then you will get random behavior.
There's actually a problem where Cisco is non-deterministic, where it will use the length of the uptime of the session as a tiebreaker.
What you talking about, Willis?
That's a Cisco behavior. You can turn that off, but by default, that's, I don't know. Did they make that? Did they turn that off by default, or is it still that way? But even
could someone please send me email to remind me to put that into the presentation?
But
as the best
Juniper, for
practices?
example, has a way to turn that on to enable that. It's called Cisco non-deterministic. That's
How about Cisco pull a route out of your ass mode? Okay. So, and the reason that I stress that is because, again, routing and figuring this stuff out is the intersection of a number of basic principles, right? I'm always going to pick the most specific route. There's only one path that I think is best in BGP. That's the only path that I can advertise to someone. When I've got all the different paths to a prefix, there are some rules that I'm going to apply. So there's always, you just think of all the different things that interact, and you can always debug what's going on until you find a bug, which will happen more often than it should. So always find the most specific route, and only consider paths to the prefixes that you can get to. So if you can't get to the next hop, and unless some tuning has been done, generally you're going to prefer the shortest AS path, and then MED, and then down to router ID, or what was it, the uptime of the session? Oh, the uptime of the path? It's not of the session. It's the route. Okay. So that makes more sense than the session, but okay. It's still not good, but it makes more sense. Right. Okay. Yes. Or if you're using a wait, which you shouldn't use, or a local pref, or you've padded the AS path, then that will happen before the route sort of as you got it from your provider. So if you want to change, what will happen by default, the 2 most common methods are you can change the local pref, which will ignore the AS path, or you can actually pad the AS path. You can make the route look further away as you hear it from a certain provider. The problem with AS path padding is while it does sort of preserve the distance concept in the aspath, well, first of all, the distance in aspath is, correlated, but, not even 50% good for actually determining which is closer or which isn't. But also, if you're sending routes to someone else and you start playing with the aspath, then they may not like it because you've taken away their flexibility. So that's why generally people will use local pref. So BGP decision algorithm, pretty standard. It's now more standard. For a while there was the RFC and then there was what people did. And it's become more converged. But the basic things are, if you have a route that you can get to, that's the most specific and you can get to, you'll follow the AS path length unless you've set something. And the setting something could be changing the AS path length or setting the local pref. So the easiest way to affect which route you're going to prefer is, let's say you wanted to depreference UUNet as heard from NLAyer. You'd make an AS path access list that says permit _ 701 _ because you don't want to be affecting AT&T also. And then you'd make a route map that says if match that prefix. If you just put the AS path access list on the peering session, then you'd only accept routes from 701. So you need to use a route map to give you more flexibility. So you'd say route map depref, match AS path 50, and then you set an extra prepend that could be 4436 or, in this case, 4436. And then you would put that, and then, then you use the route map and you'd say, if I match that, then I set the local pref lower than 100. I'd set the local pref to 90. We'll talk a little bit about this more later. I just wanted to show you one of the concepts. So AS path, you can prepend or you can set the local pref lower. Yeah, I just noticed that. To extend it. So router vendors. Cisco, Juniper, how many people for routing use PC hardware, server platform? Quagga, Zebra, anyone still using GateD? Not that I'm aware of, okay. Anything else is doable, a little adventurous. The main thing I would remind people is if it looks like Cisco but isn't Cisco, then test everything because there'll be some subtle differences, and you may have to remember what's show IP BGP neighbor advertised or show IP BGP advertised neighbor, or what is the exact syntax. Basically, everything will work for the pretty starter topologies, but when you get into more complex BGP policy or BGP topology, that's where you become more and more adventurous, straying from the path of the same vendors that everyone else are using. And you have to remember, if you use Cisco, Juniper, and Foundry might be getting into there, where if you have a bug, if you have a problem, at least a significant portion of the internet is seeing it. But if you use, Joe router, then you may be having serious problems that no one else is seeing, and then your customer, will be unduly unhappy with you. Right. I mean, I don't think I've ever caused a major meltdown of the internet by using my own BGP implementation. I think that's caveated properly, but I certainly have caused myself problems for reachability of my own prefixes by using my own BGP implementation. Right. I mean, the key thing is you make the updates and they're not properly formed, and then you find that different vendors didn't do good error detection, and then you find some vendors accept those routes and some vendors say those routes are bad.
Well, that's the worst case scenario where some vendors will accept and propagate it, and then others will
see that as an error and
drop the session.
Right. So one thing we didn't talk about, and if you look at the BGP protocol, if you see a route that's not valid, either syntactically or semantically, you're supposed to actually send a notify message and tear down the session. So with all the stuff that we talked about all the work that goes on when you advertise or de-advertise a whole bunch of routes, you can see that that would be bad if it happened in sync across all vendor A routers couldn't talk to all vendor B routers because there was just a route that they disagreed about whether it was valid or not. And so you want to avoid that. But basically the other things were, when I first gave this presentation, God help me, 14 years ago, there was actually a section on not running full BGP, but filtering and doing partial BGP. But it's effectively the same cost to buy any device that you would actually run BGP on will have enough RAM nowadays and enough forwarding cable to run full BGP routes. I say that even though I've got a 3B in my network that I'm hacking up. How many people? I'm sorry. Was the shiny bald man? What? On one of my routers for Usenet. Well, if you get your point and where somewhere else, then there won't be a problem. Right. That's my theory is that next year when this is presented, is that IPv6 when it continues to not be adopted will drive deaggregation in the IPv4 space, which will then cause problems, and then we'll all set up massive tunnel nets and we'll have Sean Doran type. I predict we'll be talking about address space that people do filtering and all the stuff from 14 years ago in about a year. Should we set up a lottery, a pool on that? It's more than 6 months, less than 3 years, sometime in there. So no one's going to blame you if you have a problem with Cisco or Juniper, and there's a lot of help that you can get. At some point, there will be a routing Rosetta Stone document or tutorial or something, and if anyone would like to present that, I think NANOG is actively looking for someone to do that. But servers as routers can work to the many gigabits level now. I mean, computers are, to some extent, almost, for everyday tasks, like not running your router in Java, they're infinitely fast and can do, at least half line rate at 10 gig. And the key thing is the things that aren't Cisco's and aren't Junipers but look like Cisco can be a little bit annoying. The Catalyst is probably the thing when people say, what should I run? I just point them to that because it's Cisco-like, it's a switch router, but then again, everything's a switch router nowadays. And you can run full BGP for the base routers less than 20K. The 48 by gig or 4 by 10 gig cards are 10K or less, so really hard to complain. Juniper MX is what people say, I want to get a good router. It really is a switch router still, architecturally, isn't it?
No, the EX is a switch router. The MX is a rebadged T-Series with a quarter of the price.
Oh, okay.
Effectively. Not really, but effectively.
So by default on the MX, when you set a VLAN, is it unique to that port? Oh, okay. So you have to do something to make it global. Okay. So it can be a switch if you want it to, but it's a router that can be a switch. Okay. Got it. And then the Foundry RX, MLX, XMR are their full BGP speaking routers that are alternatives. And they basically work for simple use cases. Force 10 also basically works if you don't torture it for simple use cases. Meaning, yes. So when you want a multi-home and you're going to use BGP, the key thing to get in the habit of thinking about is what do you want to accomplish? What are you actually trying to get as the net result? What do you want to advertise and what do you want to accept? And as long as you go about it, thinking about it like that, that's really the mindset that you need. So think about it in advance, make your access lists, and then you can set up the session and it'll do basically what you want. You may need tuning. You may find that the traffic flow is not right or you have performance problems or that you forgot about a prefix, although that probably doesn't happen. But plan your configuration and start implementing it before you start typing. So what's your policy? I want to advertise all of our routes, all of them, but only our routes. So don't advertise third-party routes. You assume your provider is doing filtering on you, but that may be a bad assumption. We want to accept all routes and let the router sort them out. And if we don't have enough memory, we can do filtering, meaning if we don't have enough memory, start with none and then add some in and see how it goes. And then as we have traffic imbalance or performance, we'll change the mix. So one thing you don't want to do is black hole Carl Denninger. Has anyone seen him on TV? He's actually in the finance. And so he was a very litigious individual who was a mainstay about 10 years ago on different mailing lists. And he and I were both customers of, God, what network was that? No, before Aegis. It was, can't remember. Net99, yes. I don't know why I was blanking on that. So, and he had, octet, .octet A.octet B, and I had octet.octet B.octet A. And I had dyslexia and started announcing his address space. And I was up visiting Panix in New York, and they got a call from Carl Denninger saying he was going to sue Panix, sue me, sue everybody because I was announcing his address space. Bottom line is, in BGP, there are these things, there are filters, but there are a tremendous number of people that aren't really applicable, because if you're large enough that you're peering with a lot of people, you're large enough that people generally aren't building filters on you. And if your provider isn't filtered and they have a mistake and you make a mistake and then you're announcing someone else's address space, that could be bad. So, because you'll black hole them. If it's more specific, the traffic will flow through to you. So, black holio, I think we know about that. Another interesting thing to remember when you think about the complexity of what you can implement in BGP is your provider has to believe that their path to you is the best one, or they could not advertise it to someone else. Remember, with BGP, I can only advertise my best route. So sometimes people will say, could you please make it so that you only advertise my route in France if France Telecom is doing more than a gigabit, and you don't hear my UUNet route as heard in California, and then I want you to statically originate it. What? Exactly. So a lot of the flexibility of what people want to do is limited by the fact that I can't advertise a route to someone unless I think it's the best path, and so that's important to remember in this context. So multi-homing, is everyone here? Is there anyone who is not yet multi-homed who is planning on becoming multi-homed? Anyone who would pay more than $50,000 for a Class C in the audience? Okay. If so, sue me afterwards. Generally, when you're setting things up, it's good to have default routes also. Now, default is one of the routes, I thought I had that in here, that's a little bit different in that default will only be sent if you actually say that you want to originate the default route to appear. But even if you're getting default route from your providers, you may or may not wish to have default routes. Why would you want it? Well, you may have a problem. Your provider may change the config and you won't get it. Why would you not want it? Well, if the BGP session's up, but their router has become disconnected from the rest of their network, then you probably don't want to be defaulting to them. So this is something you can think about. Do I want to have default or not? Generally, I would say for most providers, it's good to have a default route as a backup because you're going to be more likely to be having, playing. If you're just learning about routing, you're going to be playing with your router more than theirs.
I'll throw in one disclaimer. Some vendors will match a default route when you say redistribute static without having to specify default originate. Cisco will protect you against that, but other vendors will not. And this has caused some global outages in the past.
I would have thought that it was on the outbound side, not...
It's on the outbound side. If you have a default route and then say I redistribute static into BGP, some routers will match your default and start advertising that.
Okay, we'll have to take that afterwards because I'm interested because it's a question of does default become a BGP route itself, or is it... And then they don't have the filters don't deal with it. Okay. So then you gather, so your outbound's easy. You can make sure that you can get your packets out. And then for sending your routes out, one thing you do not want to do is tie your routes to an interface. You always want to you want to make sure that they exist basically forever. You want to have some routes that go to a loopback, null zero, something like that, because you don't want to have an interface going up and down and have your route go up and down. That will cause you massive problems. So you create your routes, make sure that they're always going, the underlying routes that have to match the BGP route always exist. Make sure that you've got at least a permit everything, at least a deny everything, and at least an access list that talks about what your ASs are, either just you or your downstream. Then insert those routes into BGP, probably do no sync and some other things. And then you're going to configure the neighbors. How many people here have configuration management systems that configure the routers for them automatically? Okay. Not sure I believe. Everyone who raised their hand. And but if you don't, then one thing you really want to avoid is half configuring a session. So one good way to do it is by typing in the neighbor shutdown or the neighbor, first line and then immediately shut down, or cut and paste, or got to help you, you could TFTP or something to make the change. If you're on a Cisco where the CLI gives you limited flexibility. So you've got, actually, it's probably not even, well, it is, might not be 60 seconds. I've seen sessions come up much faster than I expected them to. Yes, Kevin?
I was going to say it's
I haven't seen 2, but I've definitely seen close to, but less than 30. So you really want to keep this in mind as you're configuring, that session might start coming up. Now,
I think the spec actually requires like 10 seconds in idle before it will try to come up. But Foundry recently added a feature where by default the neighbor, when you create it, comes up in shutdown state, which is a very good thing that people should ask Cisco to do.
That is nice. I do like that. So one important thing also to remember is, with BGP, session comes up, I will send you all my best routes through the filters, and then I'll only send you changes. If the session comes up and I start sending you routes before the filters are in place, and I apply the filters, the routes that already went through, you're already going to hear unless I do something which we'll talk about to reapply those filters. So that's why this is very important. So neighbor configuration, if you have 2 neighbors, put a description in, say version 4, even though it will be next hop self, set next hop self, because God knows what weird topology you might get into with an Ethernet. If you have a provider that asks you to do EBGP multi-hop, change providers and don't use them. So just directly connected. I didn't say that. I just said, you want to have a prefix list and a filter list that is only my routes and only my ASs. You want to have a prefix list and a filter list that says either, in this case, the filter list 1 is just a placeholder for everything. You don't need it there. It's sort of just it's a reminder when I look at a config, it reminds me, oh, I'm allowing everything. And then no bogons means don't allow RFC 1918, don't allow, I generally don't take unallocated address space and filter it because, well, pretty soon we won't have any real unallocated address space. I mean, multicast, whatever. But the key thing there is, I think, don't allow your own routes in unless you're specifically allowing customers to take them. And then test it. Do show IP BGP before anything is up. You should see your routes. If you don't, you won't expect anyone else to see them. You have to see them before you can send them. When the sessions are up, do a show IP BGP neighbor advertised. I think if you're on a Foundry, it'll be show IP BGP advertised neighbor IP address backwards or something like that. But and you should see that you're advertising those routes. Go to a looking glass. Is there a nitrous.digix.net anymore? Okay. Google looking glass, and when I find a looking glass, and see how other people see you, or routeviews.routeviews.net, or route-views.routeviews. Yes, okay, something like that. Google route server and go in and look at it. And so that's what's really very important is, remember, your inbound path is influenced by how people see you. So if you want to see how people are seeing you, you need to go outside your network. You may also be able to trade, get servers on other networks. Just part of general network debugging is making sure that you've got the flexibility to see how people get back to you. I remember one of the challenges that I've had over time is if all your friends start connecting to you, then all of a sudden, all the boxes that you set up all over the internet that help you figure out what's screwed up on your network don't work because they're now on your network. And this is a recurring problem that I seem to have. So preferring routes. We talked about this a little bit before, but the easiest way is to match on the AS path and prepend the AS path or use local pref. And pretty much everyone, I just recommend that people use local pref. So just the argument here goes, let's say that I am an edge network and I'm connected to provider A and provider B. And I've got a much bigger pipe to provider A than provider B, which I would argue is your fault, not the rest of the internet's fault. So what do? I prepend extra copies of my autonomous system number on the smaller pipe, on provider B to the smaller pipe. And what does that do? It makes it look further away, which means less traffic will flow to it. And I would say plus or minus 50%. It's not going to be 90%. It's not going to be 10%. It's, plus or minus 50% of the net's going to honor that. And the other 50% will be using local prefs, and they won't honor it. And the idea there is, the argument against using local prefs is, some providers at the edge of the net are trying to tell you what to use and what to avoid. And when you use local pref, you're throwing that information away. But I would say, for simplicity, probably use local pref to prefer routes. Also, if you have downstream customers, you pretty much have to. Because if you start playing with the aspath, your downstream customers are going to get unhappy. So outbound is easy. You can always set static routes. You can do route maps. Setting your outbound is easy. And as a corollary, setting your inbound has to be not easy, because your inbound is someone else's outbound. Then they can completely control it. So it's a little bit more complex. How do you make routes get back into you? How do you select how people get back to you? It's a little bit less subtle. It's a little bit more like sledgehammer. You can deaggregate or selectively deaggregate. So you basically say, provider A, provider B, I can aspath pad, that didn't work. So what I'm going to do is I'm going to announce half of my 2023 out this path. So at this path, it's going to get the other half, and this path will go to 23. It'll get just the 24 worth. It's not that kind to the internet, but people certainly do it. Yes?
You can also selectively advertise with communities. So have your transit provider only send to a couple of networks as a way to reduce what comes in.
Yep, we'll get to that. So you can't get down to the granularity of saying the CEO of the company that is my customer lives in, Joetown and is on Joe BobNet, and I wish to make his IP address come back into me via my provider A pipe. That's what you can't do. You can say, pull more traffic here, or with communities, which we'll talk about, you can get a little bit more finesse. But ultimately, remember, Joe BobNet can always set a static route back to you through whatever they want, and you lose control. It's the corollary there. So, first method, advertise more specifics. Second method, aspath prepend. So if you want to advertise more specifics, you'd have a prefix list that is the 23 and the 24, and then a prefix list that's just the 23, and then you use different prefix lists to each provider. The other way is communities, which I didn't go into in great deal because, as I figured, we have about 8 minutes left. The BGP community is one of those attributes, and it's just a number that you put on a route. And what people do with it is they let you put numbers on the route that influence how they handle your route. They also can send you those BGP communities that tell you something about the route, that tell you how much they prefer it, how far away it is, how they heard it. On the outbound side, on the inbound side to them, the outbound from you, you can use the community to tell the provider something like, prepend this route once to 701, but not to anyone else. Or, if you hear this route from me at multiple locations, don't prefer this location, prefer some other location. So you can actually, often the providers will say, here are my list of communities, and if you set this community, it will set my internal local pref below 100 or above 100, as I hear it from you. How many people here have not used BGP communities? How many people have not used communities but have seen their providers that have list of BGP communities they can set? Okay. So if you're curious, I would advise you look at the NANOG in the Dominican Republic. There was a BGP 102 presentation that talks about the BGP communities and how to use them, and has an example of a whole network, and one of the things it's set up is communities.
I also did a presentation back in one of the Seattle ones you can find in the archives. It's like how to implement a complex community system with a whole bunch of details, which is advanced topic, but it's there.
Yeah. In general, providers don't offer you these things unless they're end layer. If you ask, they'll give it to you, but because it involves, basically if people have never set communities, learning about it, they don't want to have, as part of the turn-up process, having to explain about BGP and look at your configs, but it gives you generally will give you a lot of flexibility. I would never buy from anyone that didn't have a reasonable community system to allow me to specify what to do, because your provider doesn't, it's not only my provider doesn't want to be woken up, I don't want to have to deal with a human to be able to do something. It's like, I love booking online. I don't want to call a human and do something because they'll do it wrong and it'll be slow. I want to be able to have the control on my own, because I may need to play with a few different things, look at a route view, see what's going on, and that's just not going to survive open a ticket, get something done, and send it back. Also, the fact that there's a community system in place means that there's a lot of good automation of the network, which means the network itself is going to be more stable because humans aren't having to go in and put little shims in for people.
But don't you know that communities are proprietary and that would be violating their NDAs if they were to send them to you, like Verizon?
Well, I might or might not buy from networks that had that kind of. Yes. Well, but it's come on, you have to admit it is fun to reverse engineer someone's communities when they won't give it to you. Right. It's a little bit harder to reverse engineer their outbound communities. But. So BGP 102 and some other presentations, communities, generally what the medium to larger guys use to change their inbound path. But again, the first ones are you can advertise more specifics, or you can aspath pad, and then communities are generally the way that people do it. So iOS commands, other than just config, I'm going to assume most people have turned up sessions, show IP BGP on a route, show IP BGP sum. Learning the output of show IP BGP sum, how to see.
Your clear IP BGP command is wrong. In Cisco, there's no neighbor. In Foundry, there is a neighbor, which is another one of those weird differences.
Okay. I'll have to edit. So one thing, just very important, if you want to reapply filter changes, the command is clear IP BGP, neighbor IP, soft. Remember the soft. Well, I would say note the clear and thus remember the soft. It is not please to gently reapply all of my filters, kind router. It is clear, which means, so the idea is remember that you must have a soft. What soft does is say, I will reevaluate everything that I've sent and see if I would have not sent something or sent something slightly differently. Is there a Cisco command, I was wondering this, that will show you the attributes in the advertised routes, not just which routes were advertised, but whether or not you got the route map right?
This is one of the big problems with Cisco that Juniper fixed, and everyone should ask Cisco for a way to see your adjacent rip out.
This is one of those things, like every 3 months I sit and say, God, I wonder if I could do that. Okay. So the thing there is, when you do a show IP BGP advertise, you'll see that certain prefixes were advertised, but not what MED is set on them or what communities are set on them as sent to one provider. So on Juniper, you can see that, and for debugging, as you get more complex, that's a useful functionality. Best practices, filter, don't advertise too much. You're going to use BGP passwords in general, which are really TCP encryption. BGP TTL hack is also good to use for security. So basically, you make sure that the providers are actually, the routers are actually adjacent that should be. That's covered in BGP. Most of the things here are actually outside the scope of this, are covered in BGP 102, but you don't need to understand completely, just enough to grab the config snippets and make sure that you start doing them as you go. Yeah? Oh, I forgot. This is one of those things we got into an argument about in Dominican. There are differing opinions about it. So, in general, for edge networks that are multi-home to two providers, I still recommend it. And I could be wrong. I've been wrong before.
Well, the point being that passwords protect you against an attack that no one has ever actually seen happen, and actually configuring the passwords is a giant pain in the ass.
It is a giant pain in the ass, although it can be fun. Okay. Next top self with EBGP is a belt and suspenders. Setting the BGP version to 4. I don't think there are any V3s out there, but good to do. Peering between loopbacks, when you get into multi-router topologies internally, you don't want to peer with the next hop being an interface, because if the interface goes down, then the session goes down. Generally, you're going to have multiple ways of getting between different routers, so you'll let your IGP figure that out. You'll have a loopback per router, and you'll peer between those. Enable soft reconfig if it isn't enabled by default. When you get when you get larger scale, you'll use peer groups. The purpose of the peer group is that any route that has all the same attributes that are going to go to multiple people, you can form the route once and send it multiple times, and it's lower CPU. It's more efficient to do it that way. You'll probably wind up using route reflectors at some point, so you'll actually want to start configuring, make your initial configurations use route reflectors so that you don't have to add anything, worry about it later on. Make sure that you prefer your, yes?
One extra note, you should use templates, not peer groups now. Templates are
Oh,
better.
sorry. I'm an old school guy.
Yeah.
Make sure that you prefer IGP routes over BGP routes. There are some equipment where that's not the default configuration. Don't read about BGP route flap dampening and think, how cool, let me turn that on, unless you actually understand the implications. Also, another thing to note, is you can actually, as we get closer to the edge, things like route flap dampening that use extra memory to remember routes that are no longer there could be really bad, because they could actually cause you to run out of memory. If in doubt, when you're peering with someone, use max prefix. Yes?
You should probably give the command for make sure that you pref internal routes over BGP. Make sure that you configure distance BGP 200, 200, 200. If you do not do this, you will break your router at some point, because Cisco has a really, really stupid default.
Some vendors do indeed have stupid defaults. Okay, we'll edit the slides and stick that in. Log BGP session state changes. I assume you have central logging systems that look at disks going bad and things like that. If you want to get more sophisticated, there's a lot that you could look at, like looking at update volume and things like that. Generally speaking, looking at whether sessions are up and down, and making sure that you look at errors, link errors, on the links that you're peering with people on are probably a good base level to do. And if you do wind up using private ASs internally, please remember to strip them as you send your routes to the outside world.
One other caveat on the remove private AS, it only removes one private AS that's in the beginning. It does not remove them from the entire AS path, which is something people forget about a lot of times.
Sorry?
Well, I don't know if you would necessarily want to filter the route or not, but make sure whenever there's a transition, whenever there's an EBGP transition, that's where you need to configure the remove private AS, because if it happens twice, like say your customer sends you a remote private AS, and then you advertise it again with a private AS, and you do a remove private AS, not remote private AS,
sorry.
it will only remove the first one and won't remove the second one.
Recent changes to the PowerPoint.
Always been like that.
Yes. What? No.
Okay.
I typed it on the plane today,
Okay.
and my fingers did not type what my brain told them to type, so I apologize. So there's a lot more. In fact, a full BGP 101 with lots of config examples and changing routes and all that would probably be about 3 hours. But if you want to look at some of the more scale, we call them advanced, but what they really tend to be about is scaling BGP. Including some configurations. There's Philip Smith has done a number of presentations at NANOG that have lots of router configs and talk about some of the advanced topics. I did a couple times ago at NANOG in Dominican. We did BGP 102 that talks about some of those topics. A lot of resources on the internet now, a lot more than 10 years ago. And if you have any other questions, any specific questions, I think we are now 3 minutes over, but you can come up and ask them. And otherwise, I hope this was helpful.